Right, second tutorial. First problem is called color rotation, and we'll tackle that. So, let's read the problem description. HSV is an alternative way to RGB, red, green and blue, to describe colors. So I'm going to assume that you learned about RGB in the first semester. We used it a lot when we were looking at standard draw. Instead of specifying the red R, green G and blue B components, a color can be described in terms of the hue, the saturation and value, V. So SHS stands for hue, saturation and value. Every color, pick any color like red, it has an RGB value, or three values to describe it in terms of the red, green and blue components. But that very same color also has a description in terms of hue, saturation and value. And this is what this whole question is about. It's also known as HSB, so B just stands for brightness instead of value. Okay, the following diagram illustrates this color model. And I'll just mention there are other color models as well that works differently, and they all have their own unique purposes and places where they work best. But this is HSV. So hue is what we usually refer to as color in ordinary language. So it's red or green or blue or magenta or yellow, one of these colors. And it is specified in degrees. Now that's an odd thing, but that's the way it works. So 0 degrees is red, 120 is green, 240 is blue. Saturation is a value from 0 to 1, and it describes how intense the color is. So if things are really bright and strong colors, it has high saturation, but as we lower the saturation, the colors become more bleached out. Value describe how bright or dark the color is. So for any color, for any saturation, we can have that color be very bright or very dark. Value and saturation are a little difficult to distinguish sometimes. In our minds, they're almost the same. But you can think of this value as a sliding scale from black to the color at its full intensity. And saturation is a sliding scale from gray to the color at its brightest intensity, strongest intensity. Okay, right. So every color can be described as RGB and as HSV. And we can convert, there are routines to convert between these two representations. So here comes the point of this whole exercise. It says color rotation. Write a program colorRotate.java. Good, I can write a program that contains a static method. So a static method rotate, it must send back, or let's see first what it accepts. It accepts two parameters, color C and some floating point value D. And it sends back a color. So it changes this color in some way. That converts the RGB values of C, the first parameter, to HSV, rotates the hue by D degrees and returns the new rotated color. Okay, so I can send this routine a red, which is at 0 degrees, and I can rotate it by 60 and it'll send back yellow. Okay, fine, I can understand that. And it says hint, the java.awt.color class contains several methods that can help you to convert between RGB and HSV values. Oh, that's good to know. Read the descriptions carefully. I'll do that. And now it says image color rotation. Add a static main method to color rotate that reads two command line parameters. The first is the name of an image file, and the second is an angle. It opens the image, iterates over its pixels, so going through the pixels one by one, rotating each by the given angle. So it takes the color of each of the pixels in a picture and it rotates it by that angle. and then it displays the final resulting image. This approach works particularly well with Albert's work because of the range of colors he employs and because there is no depiction of anything natural. Yeah, I think if I remember correctly, with this color rotation, many images that even brightly colored images, natural images of people or places or nature, looks a little odd when you just rotate the colors. But Joseph Albers, was an artist from Germany, but he worked mainly in the United States, and he pioneered the use of color and color theory in the teaching of art. This is his Wikipedia page, but there's not much art on it. But if we look at his at the Google image search, we find many of his artworks. They're all very abstract. They are very graphic designy, if you know what that means. And as you can see, he plays around with color a lot. And I mean, his idea was to investigate how people perceive an image based on the colors of that image. Even though the images are identical, let's look at this one. These images are really identical, except that the colors are different. And I think, if I remember correctly, he did experiments where he asked people, he showed them these art and said, okay, how does this one make you feel? What does this remind you of? What emotion do you feel when you look at this picture? So that's Albers, I guess he would have said. So we're going to use Albers' work. Good. Here are some examples of the programs working. Suppose that Albers-01 contains the following picture from Homage to the Square, or Homage to the Square. That's a book that Albers wrote that kind of introduced his theory of colors. So that's one of his artworks. Then the following commands produce the images below. Okay, so if we rotate this blue inside red by 60 degrees, we get this darker blue inside yellow. If we rotate the same image by 120 degrees, we get this pink inside green. And if we rotate it by 180 degrees, we get brown inside cyan. And then there are some images for us to download, and I think that's the end of the exercise. Let's just go back a little bit and see. Of course, if we rotate by 180 degrees, we get right back where we started. But we can see from 0 to 180 changes red to cyan. And that's exactly what happened here. The image used to be red border, and then it changed to a cyan border. And inside, there used to be a kind of dirty cyan, which I guess would be here. If I rotate that by 180 degrees, I get a orangey browny color, dirty orange, which I guess is an accurate description of this. So it all makes sense. Okay, let's just recap. I have to write color rotate.java, add this static method, which I'll just copy somewhere now. And I've also got to write the main that applies this to an image. Okay, that's perfectly clear. Let's do that. So I've set up the project and the package, but I haven't created the file. It's new Java class called color rotate. American spelling, I see. Well, that is perfect. Okay, there is my routine, and it must be public and static. And I'm going to write the code right in here. But of course, Eclipse complains, Java will complain because color, it doesn't know about color, but I can hover, and Eclipse suggests that I import color from java.awt. That fixed that. Now it's unhappy because I'm not returning anything, but I'll get to that in a second. Since I'll be using pictures from the standard library, I'd better make sure that I have that. So build path, configure build path. libraries, class path, add jar from here, and apply and close. Okay, now it's ready for me to use. Okay, and I think I'll write main. Will I write main first? No, let's do the color rotation. So I've got color C, and I need to find its HSV values. Okay, so let's see what methods I can apply to C. Brighter, I can create a brighter color from C. I can make it darker. Get alpha, that's not important for us. There's no explanation, but not so important. Get the blue component of the RGB triple. Get color components. What does this do? Returns a float array containing only the color components of the color. So that's RGB, I think. Then there's something called the color space, which is a different kind of object or class, but I don't even know what that is. Get the color space, get components. Oh no, nothing about HSV here. So where are all these famous methods? Ah, here we go. Now these methods, I think, are static. Are they? Maybe they're not. Oh, here we go. Oh, good. This is something I can use. Get HSB color. But okay, right, hang on. So, these are all instance methods, and I suspect that the methods we are looking for is actually, they're static. So I'm going to look at the methods in color by typing the class name dot, just like I would type math.py. Here we go. Yeah, see, these are the colors we saw before. Sorry, the methods we saw. We saw these two methods before, and they are static. But this one looks good, except it uses brightness. Oh, because brightness and value is the same thing. Yes, good. Fine. Right, so if I have the hue, the saturation, and the brightness or value, I can use this method to create a color for me. So I've got to get these values, rotate, and use this method to get a color. Okay, right. So how do I get those values? Let's just go back and see. C dot get color components. I just don't want the wrong one. Get components. Get RGB components. That's definitely not what I want to do. Okay. Oh, hang on. I think I know what I want to do. Let's go back to color. Look, I'm stuck. I'll admit it. I'm stuck. I don't know what to do. But maybe I should work backwards if I'm stuck. I mean, I saw that routine that can create a color, this one, but if I give it an H, an S, and a B, that'll return a color. And that's ultimately what, at the end, I want to send back a color. So I think I will use this one. H, S, and B can stay as they are. This sends back a color, which this routine will return. Okay, now I need a H variable, that's the U, just to remind myself, an S variable, that's the saturation, and a B variable, which is brightness or value. Okay. Eclipse is still complaining because I haven't initialized these values, and that's the missing step. I've got to find these values, find H, S, and B, and I do this a lot. I write a lot of code, and sometimes it's difficult. So then I write little notes for myself, and then I've got to rotate H by d degrees. Okay, so still don't know how to do that, but I think I can do this. I'm simply going to say h plus equals d. Once again, it's complaining so much that I'm going to put zeros in here. Now everything is initialized. Okay, but this was an easy step. I just added the angle to the u, which is from 0 to 360. All I need to make sure of is that this thing won't bomb out if I give a u that's too big. Because what if it's already 350 and I rotate it by 20 degrees and I get 370? So it says the S and B component should be floating point values between 0 and 1. So numbers in the range 0.0 to 1.0. That's fine. That's what I'm planning. That is fine. The H component can be any floating point number. The floor of this number is subtracted from it to create a fraction between 0 and 1. This fractional number is then multiplied by 360. Oh, so S and B must be between 0 and 1. But H can be something like 7.5. And how this program interprets that is to say, take the floor, so that'll be 7, and subtract it from H. So H minus, I'm going to write like this. Oh, better put this in comments as well. Minus the floor of H is equal to 7.5 minus 7. Floor is simply this largest integer that is smaller than this number or equal to it. Okay, and that's equal to 0.5. And then this is multiplied by 360. And that will give 180. Okay, so in fact, H is almost also between 0 and 1, except it can also be from 1 to 2, but then 1 is subtracted, or from 2 to 3, but then 2 is subtracted. Okay, so when I added this angle to H, that was a mistake. I should have added the angle divided by 360 degrees. Okay. Yes, that is what I should have done. So if, let's say I want to rotate by 180 degrees, 180 divided by 360 is 0.5. Half of 360 is 180, so it's 0.5, and I add that to H. So if H was already 7.5, that's 180. I'll be adding a 0.5, so that makes it 8.0. Subtract the 8, so that H is, the result is 0. And then 0 times 360 is 0, which is exactly what I want. I hope you followed that, but all it basically means is that H is not measured in degrees. It's also measured from 0 to 1, except it's allowed to be bigger than 1, I guess, or smaller than 0. Right, so all this mathematics can go. All I need to do now is to find H, S, and B. Now, let's go back to my C dot. I definitely want to get something. I want to get the color components. But what is this going to send back? Or is there a HSV? I can get RGB. I can get the RGB components. Okay, so let's try to use that. Let's see what it says. It returns a float array containing only the color components of the color. They mean RGB. If comp array, the parameter, is null an array of length 3 is created for the return value. Yeah, that sounds good. Otherwise, comp array must have length 3 or greater, and it is filled in with the components. Okay, right. So if I pass a null, it'll create a new float array, and it will send back RGB for a color in that float array. Good. Okay, right. So I'm going to say float array RGB is equal to c.get color components. And I'm going to use this first routine, and I'm going to send over a null. So this means that it'll create a new array of size 3 with the RG and B values inside. Okay, now to convert RGB to HSV, let's see, wasn't there a routine down here? Yeah, here we go. RGB to HSB. What does the description say? Converts the components of a color as specified by the default RGB model, that's what I've got, to an equivalent set of values for hue, saturation, and brightness. That are the three components of the HSB model. If HSB argument is null, this last float array here, so I send over 4 parameters, R, G, B, and HSB vals. But if HSB vals argument is null, a new array is allocated, so it works just like color components. If I send over a null as the 4th parameter, it'll create a new array. Good. Otherwise, the method returns. Yes, I don't care about that. Okay, fine. This is what I want. So I'm going to have another float array called HSB, and it'll be color RGB. What was that called? 2 HSB. I have to send over the red, which is the first component of this array, so it's RGB 0. The green, RGB 1. The blue is RGB 2, and that I want to be null, so it will create a new array for me, and it's sending it back in this array. So instead of having 3 separate variables, I have one variable which is an array with 3 slots. And why is it complaining? It's not applicable to float null. Why? What does it want? It wants integers. I guess from 0 to 255. Oh man. Okay. I'll create integers. Int RGB 0. I strongly suspect that RGB 0 lies from 0 to 1, but I'm going to multiply it by 255, and we'll see if I'm correct or not. RGB 1, 2. Okay, and now this can be RGB. Okay, let's take that out. B is duplicated, but I'm going to get rid of these. Okay, fine. Let's just review what I've done. I first call get color components with a null, which creates a new array of floats, three floats, and it puts the RGB values in those floats. They're floats, so that's why I think they're from 0 to 1. This is often used. But now I want to call this routine that'll convert the RGB to HSB, and it wants integers. So that's why I am multiplying these floats by 255, because obviously R can't still be from 0 to 1, because it's an integer. It can either be 0 or 1, and that means I'll only have 8 possible colors: 000, 001, 010, and so on. So that's why I think I should multiply by 255. If I multiply a float by an int, I get a float, but I'm casting it back to an int, and I put that in R. So I'm making a few assumptions here, but I think that they are correct. Of course, I can test all of these assumptions by just calling this and printing this array, and then calling this array with values that I know and printing out the result. Okay, never mind that. Now I want to rotate the U, and the U is the first element of this HSB array. And then I'm sending over the H, the S, and the B component. People use this H and B interchangeably often. Other people actually make a difference between B and H, B and V. So some people use brightness, some people use value. We'll see if we're correct. Well, it doesn't really matter because we never touch the brightness or the saturation. So we won't really know which one we are using. Even if there is a difference in how they behave, we don't modify the brightness. Okay, fine. I think this is correct-ish. This is a difficult program to test. I mean, it'll take too much effort to test. I'm too lazy. Sometimes it's easier, especially if it's a small program, to just write it and see if it works. That doesn't mean I just write anything. I try to be as correct as possible. Right, let's write the main program. Make a new picture called pic. It's a new picture, and I'm going to give it a file name, and that will be arc0. I'm also going to say the angle is double dot parse double arcs1. We did that so many times in the last semester. Now I want to record the width of the picture and the height of the picture, and I'm going to have a nested for loop. This should be old news to you. Y is less than h, y plus plus. Okay, right. And for every pixel, every xy coordinate, I want to get the color. So pic.get x and y. I want to rotate it. I'll call it color D. And I'm going to use my own method. Rotate the color by that number of degrees. So rotate C by the angle. So this will rotate every one of the pixels by the same angle. So if there's red in different places, all those red will change to yellow, for example. Now it's complaining that rotate wants a color and a float, and I'm trying to send it a color and a double. So I think I'll just replace this by exactly the same thing, but just with float. You may not have done this in the first semester, but you're all clever people, and I expect you to be able to just easily pick that up. And the last thing I do is to set x and y to D, and at the very end I want to show pic.show. Right, so I downloaded 2 other interesting images for us to work with, but maybe we should just test the images in the tutorial. I'm gonna save image as, just save it on the desktop, and I'm gonna import it into Eclipse by moving it there. Copy files, yes. Okay, so Albers is this little picture, and I'm going to run color rotate. Run color rotate. Java's complaining. I fixed that by going to run configurations. Arguments is $string prompt apply and just run it immediately. And RW144-2020 and how many degrees? Let's go 0 degrees because that should look exactly as the original, just like the original. There it's running, and there is the result. So let's just, there we go. So rotating by 0 degrees gives me this result. That looks right. Let's run it. In fact, I think I can just do this. Yes. Let's rotate by 60 degrees. And I get this. And I think this was also in the Tut. So, yeah. Rotating by 60 degrees gives me that. Rotating by 120 should give me green with purple in the center. So run again. 120. Okay, that looks right. I get what I expected. Okay, fine. Let's do some experiments with these other pictures. Let's open Tut2.1. So this is a famous painting by an artist, a Russian artist who lived in Cape Town. It's called The Chinese Girl, or sometimes it's called The Green Lady. And I really want to change her skin color back to, well, a little more normal. So let's say she's green. What kind of green is she? Almost a bluish green. So let's say she's there about 160 degrees. And I want to change her skin color to yellowish, humanish. Let's say it's 60. So 160 to 60 is minus 100. So let's see what happens if I run minus 100 and I'm gonna run Tut2.1. Okay. The student, oh, okay. Well, I won't say it's not beautiful, but it's not exactly what I wanted. It ended up in green territory. So maybe she was much more blue than I expected. Maybe I should go minus 140. Let's see what happens with 140. Minus 140. Okay. Skin is a little more natural looking, but of course her lips were red, and now they've changed to blue because all the colors in this image have been rotated. Oopsie doops. So I think I like the original better. Right. One last image. This is an artwork installation in Portugal, and I just thought it would be fun to rotate it by some number. I don't even know what. And I'll go Agueda, not too epic. Let's go 180. Let's see what it'll look like. See, it just looks like a funny photograph negative. It doesn't really affect me that much. I can't say I'm touched. Maybe it'll work better with a smaller 20. It looks like a funny filter that you can find on Instagram or somewhere. Okay, fine. I think I'll stop. Natural photos just don't work very well with this color rotate, but I think the Albers images really did the trick. So that's color rotation.